for good reason too. When we talked about the limit as x approaches infinity, either positive or negative infinity, and in this case, when you have the graph, it's really easy to notice that it's just 2. The question is what happens when you don't have the graph? So, there are a variety of ways to do it, but I know you. You want the shortcut, right? Let me be clear. Whenever I ask you the limit as x approaches infinity or negative infinity, it is only showing up on a multiple choice test. It is never showing up on a free response. But guess what? Nobody cares about your work. Nobody ever looks at it, right? So we don't have to be 100% mathematically correct in showing all of our steps, because in the end, when you guys actually do it, nobody's actually ever going to look at it. You guys are taking a multiple choice quiz for me, you're taking a multiple choice test for this unit for me, and I'm not looking at your work. Originally, when you were taught this, the mathematical way to do this is to take the highest exponent of x in the denominator and divide everybody by it. This is the mathematical way of doing it that nobody cares about, unless you're going to become, a pure mathematician. That's going to pull off, because that's probably the track he's going to. If you can make it out of 77 without pulling your hair out. That's because I'm having fun. So, back in the day, I believe Mrs. Roach introduced it to you by dividing everybody by the largest exponent of x in the denominator. What ends up happening is you get the limit as x approaches infinity, 2 plus 1 over x minus 3 over x squared over 1 plus 3 over x minus 4 over x squared. And then what we would say is that because x is approaching infinity, that as x approaches infinity, that goes to 0, that goes to 0, this goes to 0, and so does this. And so you get 2. Now, that is the 100% mathematical way of doing it, because what I've done to the top, I've done to the bottom. And so all I've done is multiplied by a fancy 1. But in a sense, when it comes to multiple choice, nobody cares that you write it out mathematically correct. This process took me probably about 1 minute and 30 seconds to write it out. I would like you to answer all of your multiple choice questions less than 2 minutes. So you're like, oh, we're under the 2-minute mark. Great. But this, I can answer in 10 seconds. I can answer any of them in 10 seconds. You can too. It's not just because I know math. But let me show you something. So I'm going to pull up your homework for a second. If my internet decides it's going to work at some point. Okay. Alright, so my technology is slow, it drives me crazy. Okay. Here's your problem set. Okay. Want to do your problem set in 5 minutes?
Yes.
Okay, look. What we did originally is I took the highest exponent of x in the denominator, right? What's the only thing that mattered in the end? The first term, right? When I went here, the only thing that actually mattered was the highest in the numerator, highest in the denominator, including the coefficients. Nobody else mattered. They all went to 0. Right? So, do your problem set real quick. If I can find it. Okay. Cross out everything but your leading terms in the numerator and the denominator. So I get the limit, x approaches negative infinity, 3x cubed over x squared. This reduces to 3x. When x gets more and more negative, what happens to the whole thing? I take a positive number times a negative number that's going towards negative infinity, and I get negative infinity. That was actually more work than I actually needed to show, but.
So the numerator, if it's to a greater power than the denominator, will it always be like
Either positive or negative infinity. But I'm going to trick you. Look at this guy. The next one. Limit as x approaches positive infinity, negative 4x cubed over x squared. So I am left with negative 4x. It's a positive infinity times a negative number. So technically I'm going towards negative infinity. You don't have to write out all this work, because you can eyeball it. Again, cross out, cross out, cross out. Oh look, positive infinity. Positive infinity. Right? Questions? Yes, Tanner.
How did 3 work again? What were you crossing? You were crossing everything.
I crossed out, I reduced, so I had this.
Yeah.
I didn't really care about the coefficients, but I crossed out my x squared reduced with my x cubed. So then I was left with 3x over 9. And then I'm going to a positive infinity. So everybody was positive. I don't know, you blinked and it was all done.
Yeah.
Wait, I blinked. Not for that long either. Like, oh, magic. Okay. So you can do all these pretty quick. The only other thing I need to show you is, or talk to you about in your notes, just so that we were all aware. How do you graph this? So, how do I graph this equation here? Which it's already graphed here. Okay, so I'm going to use this graph to show you guys what I would do. So step 1 is to find your horizontal asymptote. I don't care for now that you abbreviate horizontal asymptote. There will be situations where I'll tell you cannot abbreviate at all. But for now, you can abbreviate horizontal asymptote. So that is your step 1 for graphing. Step 2 would be to factor. Three is to cancel. And that's your remove discontinuity. And 3 is your little open dot. 4 is your vertical asymptote. And then 5 is to pick a point on the other side of the vertical asymptote to see where the other part of the graph goes. So that up here is your step 5. So what I do is I look and I'm like, okay, when I pick negative 5 and I plug it in, am I a positive number above 2 or am I a number that is below 2? Because that'll tell you which of the two to graph. 95% of the time, they're always opposite. At least for what you guys are going to see. Questions? Alright, you guys have the rest of the class period to work.